Hello everyone, this video is going to be about solving equations with variables on both sides. Let's start with some examples, and then at the end I'll go over the steps it takes. Number 3, 2m plus 12 equals 3m minus 31. The first thing I'm going to do is I'm going to remember our goal. Our goal is to have m equal to something, the variable equal to something else. So that means I need the variable on its own and I need it positive. Because I want it to be positive, the best way for that to happen is if I move this 2 over here. That's 2m, I'm going to subtract it from both sides, and that's going to leave me with just m on this side. And then I have to move this. m minus 31 equals 12. That was the best first step because now I just have that positive m and I'm not going to have to divide anything at the end. The only last step I have to do is to move this 31. That's a negative 31. It gets moved by adding 31. And I end up with 43 equals m. Then we're going to check that. 2 times our answer, 43. We're going to take this and we're going to put it for m over here on the right. Plus 12 equals 3 times 43 minus 31. So 2 times 43 is 86 plus 12 equals 129 minus 31. This one's going to make 97, and this one is going to make 98. Oh, okay. A 6 plus a 2 makes a 98. So 98 equals 98. We did it right. I'm going to write down number 5, and I want you to solve it and then check and see if you got it right. You can pause the video here, and then I'll show the answer in a second. Is 2/3, which is 0.6 repeating. I would prefer the fraction. And the reason why I would prefer the fraction is because of this when we check it. So the answer was a equals 2/3. If I did that with decimals, with the decimal answer of 0.6 repeating, I would have had to round things whenever doing that checking step. Let's go to number 11, because the next couple, 7 and 9, those are just like 3 and 5, so now we're going to go down to 11, because that one looks different. 8q plus 12 equals 4, 3 plus 2q. I'm going to distribute first to get 12 plus 8a equals 12 and 8. Oh, I said a, but that's a q. We have 8q plus 12, and then I'm going to reformat the right side. I'm going to put the letter first, 8q plus 12. These look like they're the same, and to verify that, let's subtract 8q, because we're trying to get our q's on one side. And let's go ahead and subtract 12. The 8q's balance out, the 12's balance out. You would end up with 0 equals 0, and this is special. Because everything canceled out, that means that everything was actually balanced. Everything was equal to each other. And because it was equal, that means that it doesn't matter what you plug in for q, you're going to have a true answer. So if I can plug in anything, that means that I can plug in everything, which means I have infinite solutions. And this will make more sense once we start graphing. it would mean that these two equations, the left side and the right side, these two parts, that and that, are actually parallel lines. Well, not just parallel, but they're actually right on top of each other. I want you to try 13 on your own, and then I'll show you the answer in a second. So pause the video. Do number 19 and 21. Six times w makes 6w. 6 times -1 makes a -6. 3 times 3w, the 3 and 3's make 9's. 3 times 5 makes a 15. Since the 6 is smaller than the 9, we're going to move the 6. You know what? Just because you might not do that, I'm going to do it differently this time. So let's move the 9, just because it is fine if you do that. This side will balance out to make 0. These two are going to make a -3w minus 6 equals 15. Let's add the 6. Last step is to divide by -3. W equals -7. 21 divided by -3 makes a -7. Now let's do that last one. Let's get these v's on the same side. Since in the end we want v to be positive, I'm going to add the -1 to the left, so that way I don't have to deal with any negatives at the end, like we did on number 19. So we're going to add 2/3 v. Since they have the same denominator, you just add the tops. 2 plus 2 makes 4/3 v minus 6 equals 6. Let's add 6. So that way this one moves to the right. The left 6 moves to the right. So we have 4/3 v equals 6 plus 6 makes 12. Then we have this fraction. If you did the last day's work, then you would know that to get rid of this fraction in front, we're going to multiply by the reciprocal, which means we're going to have a 3 on top and a 4 on the bottom, and a 3 on top and a 4 on the bottom here. Same thing. Then 3 balances with 3, 4 balances with 4. V equals 12 times 3 makes 36 over 4, which equals 9. Watch part 2 to get the steps. To summarize the steps that we used whenever we have an equation and there are variables on both sides, we did this. The first thing we had to do was we had to check for distribution. You should check if you need to distribute, and it's usually best to do that first. It's only once you're pretty good at solving equations that you might decide not to distribute as your first step. After you distribute, you remember that our goal is to have x equal to a number. That means that we need that variable positive. So we want to move one of the variables either on the left or the right so that the end of that answer has a positive coefficient. Like, let's look at number 9. Number 9, we have 3r and 5r. If I subtract this 5r, then I'm going to have to make a -5r over here, and that's going to make a -2r, and then I'm going to have to deal with a negative in the end. But if I move this 3, then I'm going to have a positive 2r on the right side, and then I don't have to deal with anything negative later. Dealing with negatives are fine, it just adds an extra step. The way you would remove a constant is by using an additive inverse. You should be used to that by now. And then finally, divide by the coefficient. Finally, the last step is to divide by the coefficient of the variable. I don't like following steps. I like just knowing how to do it. Know the goal, x equals to a number, and then do whatever you need to do to get x by itself and get the numbers on the other side. There is one more level of difficulty past this that we'll do in algebra, and even that level isn't so bad. It just looks like it is, and you might get confused, but if you pay attention, it'll be no big deal.